All right, so we're talking about logarithms. Short way to say it is logs. The ln key is also natural log, and we'll get more into that here in a few minutes. Logs are related to exponential relationships. So do you remember how when we were talking about root functions, like if we had the square root of x, how we could express that in exponential form by saying that that was x to the 1/2 power? And those were equivalent statements. We did a whole chapter on that. So when you're talking about logs, we can write this out, that logs are just, it's another way of expressing an exponential relationship. And just like when we were dealing with some square root problems and some cube root problems, it was kind of impossible to deal with them unless we put them in fractional exponent form. You know, like when we were trying to divide the cube root of x by the 5th root of x, we couldn't really deal with that unless we put them in exponential form, right? And then we would subtract their exponents. Well, there are some problems that are in exponential form that we did not know what to do and how to solve them. And so this is going to allow us to solve for them. Remember in our homework we did on page 470 and 478, we would have t as the exponent, and t was standing for the number of years. And the question was like, hey, how many years would it take for you to reach a certain number? And we had to just guess and check, right? We had to put different numbers in for time until we got the answer that we wanted. Remember doing those problems? Those of you who did that assignment, we were just guessing and checking. And we'd say, oh, it took like 3 years for that to happen, or it took 6 years for that to happen. Logs are going to allow us now to actually find the exact number without having to just guess and check. All right, so it's just another way of expressing that exponential relationship. So I'm going to give you now 2 sentences that are going to become very, very important for you in understanding the relationship between logs and these exponentials. Okay, very important you write these down. They're going to kind of become your mantra or your 2 sentences that are going to help bring you back home. Because there's going to be times in this that you're going to get lost. You're going to be like, I don't even know what's going on anymore. I'm so confused. And when you come back to these 2 sentences, all of a sudden things become clear again. So I want you to write these down, highlight them in your notes, circle them real big, something. Okay. First one is, the base is always the base. In exponentials, we have a base, and in logs, we have a base. And so the first sentence here is, the base is always the base. Your second sentence is, the answer to a log is an exponent. The answer to a log is an exponent. These 2 statements are always going to bring you back to your home base, so to speak. Bring you back to your center. All right, so let's take a look at an exponential relationship. Y is equal to b to the x power. Everybody agree that that is an exponential relationship, where x is your exponent. that's what we call being an exponential form. And we are going to rewrite that in log form. And we're going to have these two sentences help us out with that. Going from exponential form to log form. Now, before we do that, we haven't even talked about what log form looks like. All right, so remember back in probably kindergarten when they were first teaching you how to print your words, print your letters, and they would give you like a lined paper, and you had to make sure that things that were supposed to be on the line were on the line, and then parts of your letters had to be below the line, and okay. So we're going to kind of go back to that concept here, because it's very important that we're neat when we're writing our logs. Now, you're not going to write these lines out every time. I'm just kind of showing it to you this first time. So the word log needs to be on this, what we call the main, the main line here. Yes, of course. I don't have lines on my paper because I'm on the screen here. So the word log is kind of on your main line. Under as a subscript that's lower than this is where you would write your base. Okay, this is called the base. So that's what we call a subscript. So if I'm going to write this log form, we're going to write out the word log, and that first phrase where it says the base is always the base, kind of gave away the answer here. The base of our exponential is clearly the letter B, right? That's what's being raised to the exponent. And so when we write our base over here in log form, we want to make sure that we write it as a subscript next to the word log. Does that make sense? All right. What does the next sentence say? The answer to a log is an exponent. So let's go back over to exponential form. What is the exponent? The x. There's your exponent. All right, so the answer to the log. Well, answers usually come after what symbol? An equal sign, yeah. Do you see an equal sign yet? No, we need one. Now, before we draw in our equal sign, we're going to leave a little space. Let's leave a little space, put an equal sign, and we are going to write our exponent as the answer to the log. It's on the same line as the word log. Okay. Now, there's a letter we haven't used yet. What letter haven't we used yet? The Y. So the Y goes on the same level as the word log. It's not a superscript. It's not like an exponent. It's all on the same level. And you have just transformed your exponential into a log. Those are equivalent statements. We're just expressing our exponential relationship in log form. The base is always the base, right? The b, that's the base of our exponent, is now the base of our log. The exponent x is now the answer to our log. There's only one other spot for the y to go, right? How do we read this in log form? What do you say? This is always fun. All right, what do you say? This is log y base b equals x. So that's the words you say. Log y base b equals x. Those are the words you say. I'm telling you how to pronounce this relationship. Log y, then you name the base. Base b is equal to x. I'm just letting you know the correct way to state this. Log y base b is equal to x. Okay. So we're going to practice switching back back and forth from exponential form to log form because this is the foundation of the rest of the chapter. And without this knowledge, it's going to be really hard. I would say impossible to do anything else. So this is key today, that we understand how to do this. All right, so let's practice some. Could someone give me a fact that they know to be true about an exponential relationship? Give me numbers. That some number raised to some power is equal to some number. Hold on, I'm getting too many. Tell me one.
A number raised to 0.
All right, so give me a number. 5 raised to 0 is equal to 1. All right, everybody agree that that's a true fact? Okay, let's rewrite it in log form. So everybody's going to write the word log. I'm going to give an example of what you should be going through your head right now as a student. Okay, like really? 5 to the 0 is 1? Oh yeah, I remember her really stressing about that because I missed that on the test. Because I did not know that, and I wrote 5 to the 0 power is equal to 0, and I need to make up that quiz, but I need to do all that homework. I got to remember to do that. I should write that down in my agenda book that the school paid for. Oh yeah, I'm doing this problem. All right, the word log. All right, the base is always the base. The base is 5, so the base is 5. And then the answer to the log is the exponent. So I'm going to skip a spot. And the exponent's 0. And then the 1 goes here because it's the only one other spot left. Okay? Make sense? That's right. Okay? Log 1 base 5 is equal to 0. Can someone give me another true fact about an exponent that doesn't involve the 0? Yes, definitely. Give me a harder one. Yeah, can we get more creative? Can someone come up with one that actually has like a fraction in it? Give me a factual statement that you know to be true.
1,000,005.
Oh my gosh. 36. 36 to the 1/2 power is equal to 6. Okay, thank you. Wow. All right, 36 to the 1/2 power is equal to 6. Is that true? Yes, it is. Because 1/2 power means square root, right? So the square root of 36 is 6. Let's rewrite that in log form. Everybody write it down on your paper. Write it down on your paper.
Can you put it back on the board?
Is that right?
How'd you do? Base is 36. The exponent is 1/2. 6 goes where the y is. Okay. And you go back the other way. Let's see. How about this one? Can you write it back into exponential form now? So easy, right up until the day of the test.
I got it.
Yep.
What you get, bro? Alright.
Base is always the base.
I got an A in here, bro. What you got?
Yep. Answer is the exponent. Remember, the base is always the base, and the answer is the exponent. Good. Very nice. Okay, so the base is 5. The exponent is -1, and is that true? 5 to the -1 is 1/5?
Yes.
It sure is. It sure is. So we need to practice that a little bit more. You got to get very comfortable in going between the two.
Will you like test us to see like if we like know if it's correct? So say like you give us like a log and then you say like flip it backwards and then you ask us if it's correct.